Definite integrals. In integration, till now we have studied about integration of different types and different methods of solving, all that without a particular boundary, right? For example, you had integral f of x dx. So when I draw that graph of y is equal to f of x, it just simply goes like this. I don't have a particular boundary, or I'm not finding out the exact area. I'm just finding out the area in which that function is going to give. So that is why whenever you are finding the integral of f of x dx, you have a constant, right? You have a plus c which is associated along with the answer. And we don't know what is the value of that plus c till now. But that problem is solved now when we learn about definite integrals. In definite integral, what happens is the previous case, that is where integral f of x dx is now limited in a particular boundary, that is area is now enclosed under a to what b. So here if I write integral f of x dx, and instead of that if I write integral a under that and b, that is a to b f of x dx, this means the area under the graph of f of x is now limited to what? A to b. That is, it is now in between a and b only. So the graph, the previous one that we drawn here, if I take this as point A and this as point B, and if I draw two vertical lines, now what does this area suggest? This area suggests that it is now integral a to b f of x dx. So that is what is the basis of definite integrals. So here in definite integrals, you will have a fixed value. You won't have a plus c which is associated with the final answer which was there in the previous integrals. Okay. Now, since we call this as a definite integral, why do we call it as a definite integral? Just because the area is limited between the two limits, that is the lower limit a and the upper limit b. So now it is limited. So therefore we call it by the name definite integral. So this is definite integral. Now in the previous cases, what we have learned is we do not have a particular limit, right? So in those cases we call it by the name indefinite integral. So there are two types of integrals. One is definite and the other one is indefinite integrals. Now in this session and the coming ones, we will be learning about what are these definite integrals, what are the different properties that we can use in definite integrals to solve questions. To learn about definite integrals, you can use two ways to learn. The two main ways are, first one is the limit of a sum. Very important, the limit of a sum. In all the board exams, this limit of a sum is mostly seen in all the board exam question papers. So it is a very important topic, which is limit of a sum. And the second topic, or the second way in which you can study definite integrals, is by taking its antiderivative. So by taking its antiderivative from the interval a to b. So there are two ways in which you can learn definite integrals. One is by using limit of sum and one is by using antiderivative from what? A to b. You may seem that limit of sum is a little bit bigger method. It takes a lot of time to solve that, but you can learn this limit of sum as well as antiderivative, because limit of sum helps you to find out how the exact antiderivative or the integral is formed, right? So in this session, we will be concentrating more about what is limit of sum and how we can do questions or integrals or definite integrals using the method of limit of a sum. So that is a very important topic. So let's focus on limit of sum here. So we will study what is this limit of sum with an example. So the example question that I write here is integral 0 to 2 e raised to x dx. So you have to find the integral of e raised to x dx, but not indefinite. It is a definite integral from the limit, that is a lower limit. The under the integral you can see a 0, which is a lower limit, to the upper limit 2, so which is the area which is enclosed between the exponential function e raised to x from 0 to 2. Now what is that area? So to find that area, I am going to use what method here? Limit of a sum. Now what is the limit of a sum method? According to limit of sum, if you have an integral of the form integral a to b f of x dx, you can find that using the way, that is limit h tends to 0, limit h tends to 0, h into f of a plus f of a plus h plus f of a plus 2h up to f of a plus n minus 1 into h. So if I substitute h, you don't know what is h till now. So let's keep that h for the time being there. Now this is a way, that is from integral a to b f of x dx, it can be found out using the formula limit h tends to 0, h into f of a plus f of a plus h plus f of a plus 2h up to f of a plus n minus 1 into h. Now what is this h? Very important, right? So if I take the graph, in the previous slide I have drawn a graph, right? So if you have a graph like this and this is from a to b, now this a to b, the interval a to b, I am dividing that into many small parts of very negligible thickness. Suppose I divide that into n small parts. So this is divided into n small parts, right? Now, if the width of these small parts is h, I am taking the width of it as h. Now, how can I find that h? This is from b and this is a, right? That is, the limit is from a and it is ending at b. So that means I can find a relation between this n, h and ab. Now, what is the relation? What is the difference between b and a? It is b minus a, right? Now, if I take this b minus a, the difference, and divide it by the total number of parts, that is n, will I get the width h? Yes. So, we know that b minus a by n is equal to what? H. So, this is the relation between b, a and h. So, look closely here. You have to have a relation between n, that is the number of parts, h, the width of each of the small part of the rectangle, and ab, which is the lower limit as well as the upper limit of the integral, given integral. So, b minus a by n is equal to h, a very important formula. Now, using that, can we do this question over here? So, the formula that we just studied here, if I say, if I am going to substitute inside this formula, what happens? Let's substitute in the formula. So, this one can be written as 0 to 2 e raised to x dx can be written as limit h tends to 0, h into, what is this h? B minus a by n, right? So, what is h? Let's find out h here. So, h is equal to b. What is b here? H is equal to b is 2 minus 0 by n. That is, you can see the upper limit is 2 and the lower limit is 0. So, 2 minus 0 by n. So, h is equal to nothing but 2 by n. So, this is the value of h. So, you got h. Now, putting that all over here, I can see that limit h tends to 0. In place of h, I am putting 2 by n. So, 2 by n. F of a, what is a here? 0. So, f of 0 plus f of a plus h, that is f of 0 plus h, plus f of a plus 2h, which is f of 0 plus 2h, up to the last one, that is f of a plus n minus 1 into h, that is f of n minus 1 into h. So, if I put all these values inside, I will be getting limit h tends to 0, 2 by n, f of 0, e raised to 0. The function is e raised to x, right? So, what is f of 0? E raised to 0. What is that? 1. Plus f of 0 plus h, nothing but h. F of h is nothing but e raised to h. So, e raised to h. Plus f of 0 plus 2h, which is nothing but e raised to 2h. So, that we got. Now, it goes like this till the last one, that is n minus h. So, it will be e raised to n minus 1 into h. Okay. So, this is what we got here. I can say limit h tends to 0, 2 by n, 1 plus e raised to h plus e raised to 2h. Now, I am writing in terms of n, right? What is h? We just wrote that h is equal to b minus a by n, that is 2 minus 0 by n. So, that is 2 by n. So, what I am going to do here is, in place of all the h, I am going to put this 2 by n. So, it will be 1 plus e raised to 2 by n plus e raised to 2h, that is e raised to 4 by n, and at last it will be e raised to n minus 1 into, that is 2 by n. So, this is what we get here. Now, if I see, I don't have a h value or inside this limit, I only have n terms. So, what happens is, I have to change the limit in terms of n. So, if h is tending to 0, that is, the width of each of the rectangle that I have divided is tending to 0, what happens to the number of parts n? It will tend to what? Infinity, because when you take that rectangle as small as width as possible, the total number of parts increases to what? A very huge number, and we don't know that number, so we put it as what? Infinity. So if limit h is tending to 0, limit n should be tending to what? Infinity. So 2 by n, then we have a 1 plus e raised to 2 by n plus e raised to 4 by n up to e raised to n minus 1 into 2 by n. So let be there. Now what happens is, here there are total how many terms? Starting from 1, you have e raised to 2n, e raised to 4n. So it is a sum of what? A geometric progression which starts from 1. And we know the sum of a geometric progression is a into r raised to n minus 1 by r minus 1, right? Yes. So if we use that, it is a 1 into r raised to n. What is r here? Each term is getting multiplied by e raised to 2 by n, because you can see that the second term is e raised to 2 by n. Third term is e raised to 4 by n. So it is increasing by or getting multiplied by e raised to 2n. So a into e raised to 2 by n, the whole raised to n, r raised to n minus 1 by r minus 1, that is e raised to 2 by n minus 1. So when you do that, because it is 1, let it go like that. Now we get limit n tends to infinity 2 by n, 1 e raised to 2 by n raised to n is e raised to 2 minus 1 by e raised to 2 by n minus 1. So what I'm going to do here is, now there is a 2 by n. So I am taking the 2 by n down over here. So when I take this 2 by n down over here, it becomes like this 2 by n. Now what is e raised to 2 by n minus 1 by 2 by n? When I apply the limit, I will get this whole thing as what? Equal to 1. And what is the only thing remaining over here? The numerator, which is e square minus 1. So I can write the final answer here as how much? E square minus 1. And this is how you do integration or definite integrals. By what method? The limit of a sum method. So we have a formula, we took the formula and we put it over here, and we substituted the values, and we got the final answer using the method called as the limit of a sum. Let's do one more question to understand this method more clearly. So now we have a question over here, that is integral 2 to 3 x square dx. Now how to do this question? Integral 2 to 3 x square dx. So you have a is equal to 2, b is equal to 3. So therefore h is equal to b minus a by n, that is 3 minus 2 by n, that is 1 by n. So what is h? It is 1 by n. Now if I take this and use the previous limit of a sum formula, that is limit h tends to 0, h into f of a plus f of a plus h plus f of a plus 2h up to f of a plus n minus 1 into h. And if I do that, I will be getting the substitute over here. I will be getting limit h tends to 0 into f of a, f of 2 is 2 over here. So what is f of 2? Put that in x square. So you will be getting 2 square plus f of a plus h. What is f of a plus h? You can see that when I put 2 plus h here, I will be getting 2 plus h the whole square plus f of a plus 2h will be 2 plus 2h the whole square, like that till a plus n minus 1 into h, that is 2 plus n minus 1 into h the whole square. So this is what I get. Now if I just open all the bracket, I will be getting limit h tends to 0, h into 2 square plus 2 plus h the whole square is 2 square plus 4h plus h square. Then 2 plus 2h the whole square is 2 square plus 4h square plus 8h plus the last one is 2 plus n minus 1 h into whole square is, you will be getting it as 4 plus n minus 1 square h square plus 4 into n minus 1 into h. So this is what I get here. Now see that you have 2 square, 2 square, 2 square till the last term, that is n minus 1. So you have a total of n minus 1 2 squares, right? So what will be the total? Yeah, what this 4 I am writing it as 2 square. So what will be the total number of 2 squares? If you have 1 n times, you will be having a sum of n. So if you have 2 square n minus 1 times, it will be having a sum of what? 2 square into n minus 1. So when you put that, you will be getting it as limit h tends to 0, h into 2 square into n minus 1, yes, plus 4h, then you have 8h, like that. So when you take 4h common, you will be having 1 plus 2 plus 3 up to again n minus 1, right? Yes. So that's what we get here. And then what you have, the last one is h square. So you have h square, 4h square, n minus 1 h square. So you have like that also. When you take h square common, you will be having 1 square plus 2 square plus up to n minus 1 the whole square also. So that is what we get here. Now taking that, you will be getting limit h tends to 0, h into 2 square into n minus 1. So I'm writing this h now as what? H is equal to, you know that it is, in the previous case we got it as 1 by n. So if I write h as 1 by n, I'm writing it as 1 by n here, then you have 4 into n minus 1, yes. Then 4h into, what is the sum of 1 plus 2 plus 3 up to n minus 1? What is the sum of n natural numbers? N into n plus 1 by 2. So here it is n minus 1. So what will be the sum of that? N minus 1 into n by 2 plus h square into, what is the sum of squares of natural numbers? 1 up to n square, 1 square up to n square. It is n into n plus 1 into 2n plus 1 by 6. Here it is n minus 1. So it will be n minus 1 into n into 2 into n minus 1 plus 1. That is, it is 2n minus 1 by 6. Again, what I'm going to change here is, I have h inside all these terms. So this h and this h square, I'm writing it as, this h is 1 by n, so 4 by n, and this is 1 by n square. Okay. Now taking this, you change the limit also. You have h tends to 0. So changing that to n tends to infinity, I'll be getting limit n tends to infinity, and you put that n inside or 1 by n inside, you will be getting it as 4 into 1 minus 1 by n plus 4 by 2, or you can cancel it and write it as 2. So 2 into 1 minus 1 by n, or this this n gets cancelled also, and this one comes inside, you will be getting 1 minus 1 by n. And here this one gets cancelled with this n, and there is an n coming here, so you can write it as 1 by 6 into 1 minus 1 by n into 2 minus 1 by n. Now when you apply the limit n tends to infinity, that is, there is 1 by n everywhere, right? So 1 by infinity, what is this 1 by infinity? 0. So you put that all limits over here, so you will be getting 4 into 1 minus 0 plus 2 into 1 minus 0 plus 1 by 6 into 1 minus 0 into 2 minus 0. So that will be 4 plus 2 plus 1 by 6 into 1 minus 0 into 2 minus 0, which is 2 by 6, which is 1 by 3. So 4 plus 2, 6 plus 1 by 3, or that is equal to 19 by 3. So this is the answer that we get for the limit, which is integral 2 to 3 x square dx. So that is how you find the integral for that particular function using the method of a limit of a sum. So this method is quite lengthy because it takes a lot of time and you need so much patience to find out the final answer, and there are tricky steps also which is in between. You have to change the value of n, you have to change the value of h. So you have to be very patient when you're doing this question, which is using the method called as limit of a sum. We have a little more easier method which we will be studying in the next video, where you can solve integrals much faster and you don't need this much time also, and we will be studying that in the next session. Now let's have a quick recap of what all we have learned in this video.
Manorama Horizon, learning made simple.